start.
Good day viewers. Today we are going to discuss about number system, and this is a chapter 1 of the book of mathematics, that is a textbook that is given. So in this textbook it is the first chapter. I have skipped this factor thinking that it will not be it will be dealt with later. But while I was teaching some students, I found that there is some lacuna in understanding of the number system. So we will start with numbering system, and that's the number system. Okay, now first of all I will go through two systems of this thing. One is Roman numericals, and later on I will go to what is called Hindu Arabic number system. Okay, we'll discuss both of them. I have introduced this one because I think this is necessary even for a general knowledge. Romans first use certain alphabets in order to indicate their numbers. For example, they said M, that is equal to 1000. Then they had D, that is 500. Then they have C, which is 100. And then they have L, that is 50. And then you are familiar with X, that is equal to 10, and I, that is equal to 1. How did this system work? One thing we will suppose I want to write 1, so I will write 1 like this. Then there is no other number for 2, but you add another 1. So you must have seen in your board outside class 1, class 2. And in case of class 3, what it is written, this is what class 3. Okay, there is a system, there is this thing, that these notations cannot be repeated more than 3 times. Some notations like L, like D, and there is another notations I have forgotten which I should write, that is this thing, that is 5. And 5, they should not be repeated at all. So this is 1, 2, 3. Okay. Now what is 4? What would be 4? 4 would be 5 minus 1. Whatever you write on the left side, that is deducted from this one. So this is 5, 1 is deducted, so this becomes 4. So okay, let's go further. I use this part of the board, or I will, as since I have seen it, can also use this part of the board. Okay, let it get dried up a little bit. Okay, so 5 will be definitely a V, that is 5. So you add on this side 5, 1, that is 6. So whatever you add on the right side, that is added. Right side, that is added. So this, if I draw a line, this would be right side, and if I draw another line, this will be left side. Okay, so this is another one, so this is 6. So you continue like that. You go to up to 8, okay? But in case of 9, how do you write it? You write 9 like you make a cross, that is 10, and then you take 1 out. So this is your 9. And 10 will be a 10 like this. Okay, now you can continue. So when I come to 50, how do I write 50? 50 I will write as L. 40 I will write XL. Okay, so I will continue writing like 50, 40 I will 41. How do I write? I write X, L1, and then you keep on continue and go up to 49, and 49 you write L into X, and on this side it will be another X and 1. So you see how big this will continue, we will be coming. So as you go to larger numbers, these notations keeps on increasing. Another thing you must distinguish here, there is no use of 0. 0 is not used. As a result, they become very, very good in geometry, but they were very poor in arithmetic and algebra. So that part of science never go up. You have read about Pythagoras, about Euclid, all you have Euclid's geometry. So geometry, etc., they progress substantially, and of course they substantially on political science, on theology, etc., they progress, but they did not progress on the side of algebra and arithmetic. The other system, so this is not part of our chapter 1, but I thought I will explain it to you, because sometimes you see these notations and you may wonder what they are. So as a general knowledge, this would be useful for you. Okay? I have another request to you, that don't try to take any notes, because these videos will be available. So whenever you want, you can always see this. So now we'll go to the number system which has been attributed to Hindu and Arabic. So this is Hindu and Arabic number system. And there are many number systems, at least there are 4 number systems. We will only discuss about the decimal number system. And this decimal number system consists of 10 digits, which starts like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. And this is our contribution, because we have been able to contribute, and that's why this is not Hindu, this is Hindu. I'm sorry, I erased that part of it. Hindu and Arabic number system, and this is our contribution to 0. So that's why this name Hindu is there, right? Okay, so we had made at one time a substantial contribution in development of mathematics. Okay, so we will start how this number system has been developed. What is this system that has been developed? I will first start with what is called a number line. What is this number line, number line, and number line? This number line is where we can find out different type of numbers. So let me first draw a line, and when I put numbers on it, it will be called a number line. Okay? So let us see this line here. Okay, so I think it's a nice line that I have been able to draw, and on this line we will show, let us say we start from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and onwards. We can keep on counting. So this is 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9, 10. I am using on the both sides in order to give you a clarity. So these are called counting numbers, where you count. You want to buy, say, 10 apples, so you will count 10 apples, okay? So this is called, this is indicated as n. And so on this, if you add, these are called natural numbers. Natural numbers. And this is usually indicated by capital N, as I have told you before. Now here, when you add 0, suppose I add 0 here. So that means I will write it like this. I put it here, another point, and I add 0 here. Then this becomes, including the whole natural number plus 0. So this is natural number plus 0. That gives you whole number, and that is indicated by W. So you have N, you have W. Now when I go on the other side, so this is natural number added O, that is a whole number. So 0 is a part of the whole number. Don't get confused here, okay? That you have to see, if somebody says 0 is a natural number. No, 0 belongs to whole number. So 0, this thing is a whole number. On this side, now since I have a 0, then the concept of negative came up. So because what is negative means something which is not me, I don't have it, but I have spent it. So that means I owe it to somebody. In order to indicate that, so the negative signs has, this concept was developed. So 1, 2, minus 3, say let us say minus 4, and this is minus 5. Say let us say minus 6. Okay? Now whole number plus negative number, negative numbers, this whole thing, this is called integer. Okay? So and these integers are indicated as Z. Okay? So this is natural number N, whole number W, but integer it is written as Z. So you should understand, when somebody gives you a notation about Z, you must understand this one. So this whole thing is there. Now you can also see that in between say 1 and 2 there is a gap, okay? And this gap, there would be a lot of numbers here. Okay, and these numbers will be what? This will be fraction, because 1 and 2, these are the numbers. So anything in between, let us say that would be half, that will be 3/4. Okay, so that kind of a thing, it will go on this thing. If there can be 1/4, of course, will be on this side. So half, no, it will be between this and this. If I talk about, then it will not be 3/4, etc. It should contain 1. So 1 and half, 1 and 3/4. So that should be in between these two. Okay, now you can see these I can represent, these fractions I can represent as P by Q, and Q is not equal to 0. Why this is necessary? Because if Q becomes 0, let's say Q is equal to 0, then this becomes undefined. So you cannot define this, because say Q, and here is 0, and here is 0. So what do? You multiply by 1, this becomes 0. So it cannot, it goes on like this. So you cannot do this. So this, because of this, this remains undefined. So we have to say that these conditions, we have to say that Q is not equal to 0. So do we understand this one now? So these fractions, when we take up in the number system, so integer plus fractions, integer plus fractions. Fractions, what I mean? I mean fraction by P by Q, where q is not equal to 0. Now, and this whole thing, and plus integer plus fractions, this we call it as rational numbers. Rational numbers. Why it is called rational numbers? Because it comes from the ratio, as if you are taking a ratio between these two. So from ratio you have rational number, and these rational numbers as indicated by q. So you have, what is it? You have n, you have w, you have integers, and then you have rational numbers. What are these rational numbers are? So you can see that any one of these natural numbers, whole numbers, integers, they can also be part of the rational numbers. How? Let us say we take 9. I can always divide 9 by 1. So this is in the form of p by q, where and q is not equal to 0. This can happen. Similarly on the negative side. On the negative side, I can do the same thing. Okay? On the negative side, I can also show you it is going to be like this. Okay? Okay. Well, I am doing this to keep you to utilize your time. Please like my channel and subscribe, because you will be able to get many more videos of different part of these things. So let us recapitulate what we have done. We have started with natural numbers. Okay, we have added 0. That has converted to whole numbers. N, this is W. We have added here negative numbers. That has converted this to integers. Negative numbers, integers, that is denoted as Z. Then included in this, so this is plus, this is also plus. We have added fraction, in the form p by q, in the form p by q, where q is not equal to 0. Okay, so we understand this. Okay, now here we have added this one, and we call this one q. So this is called rational number. Okay, and this we indicate as Z, and this we indicate as Q. Now there are very things in the chapter 1.3. If you look at chapter 1. Exercise 1.3, there is some interesting questions, and you can go through them and you can answer them also. Okay, like okay, so and in the number line there are infinite number of points. There are infinite number of points in the number line. Okay, so here -1, -2, -3, in between 0 and 1 you will have half, you will have 3/4, you will have 7/8, you have many others numbers, infinite number of this thing. Every point on this number line will give you a number. Okay, so there are some questions here. I would like to show it to you. Is 0 a rational number? Yes, 0 is a rational number. Why? 0 I can write it like this, and so 0 will become a rational number, because 1/0, 0, so I can make 0 here, 1 into 0, so this will be there. On the numerator 0, numerator 0 is no problem, and this satisfies P by Q, right? This satisfies P by Q, where Q is not equal to 0. So G0 is this thing. Find 6 rational numbers between 3 and 4. How do you find 6 rational numbers between 3 and 4? Very easy. What you do, you have 6 rational number between 3 and 4. What you will do, generally they have said they find 6 rational number. So you have got 6. So 6 plus 1 you do it. So that becomes 7, right? So how do I get 3/7? 21/7 is 3, and 4, how do I get? 28/7. So what would be the 7 numbers here? It could be 22/7, 23/7, and then continue 24/7, 25/7, 26/7, right? How many you want? You want 6. 1, 2, 3, 4, 5, and you can also add 27/7. Okay? Because if you go to 28, you will hit 4. So you don't want to hit 4, and you don't want to start with 21. So these are the these are the numbers you will get. So this is very easy. How do you get? What do you do? What did I do? If you want 6, you add 1 up. You here add 1. So this 1 I have added. Why I have added 1? Because so that I can expand this. I can have 7 at below, and then I can get 3 and 4, and I will get this gap in between, and I will be able to do it. Again says 5, same thing as this thing. It is between 3/5 and 4/5. So you can easily use the same technology to do it. Well, how you will do it? You use 3 and 4, right? Here also 3 and 4. So let us say I can take out 1/5 out, right? Okay. What you can do, this is another way of doing it. You take, this is called 3/5, and same things, between same numbers, 4 and 5. So I can take out outside 1/5. So it becomes same like between 3 and 4. I go through the same motion. So it should be 22/35 and 23/35, and you continue doing it, and then you have to 27/35. Okay, so this is the way you can easily do. Do not get confused with this kind of this thing. Okay, it says then question number, this is question number 3. previous one was question number 2, and so I hope you have been able to find out how to manage it. So instead of 5 it was 7, so you can take out 1 by 7 and you can do the same type of continuation. Now there is and this is very we have to include one number which is not rational, which they are call it irrational number. Irrational, जो rational number नहीं है, rational number and it is not a rational number, so you put IR before this, so this becomes a irrational number. So there are irrational numbers that has been found, and they are by the Greeks. How they were finding out? See, Pythagoras, what he did, he took 1 unit of length on this side and he put a perpendicular here and took exactly that 1 unit here, and then he tried to find out what is the length of this. What is the length of the hypotenuse? Let us say it's O, this is A, this is B, and so he said, okay, what would be the length of OB? See, since this is 1 unit, since this is 1 unit, this is also 1 unit. So what would be this? So OB square would be equal to 1 square plus 1 square, that is equal to 1 plus 1, that is equal to 2. So OB equal to root 2. Okay? Now, how do I put it on the number line? I could have done it here, but I wanted little bit of opening so that you can see this thing. You put take a compass, put this one, and here you do it like this. So it will fall on the number line. And this root 2, you cannot put it like P by Q. So this is not a fraction. So not a fraction, root by 2. If you now do it and calculate the value of root 2, this becomes 1.414 and this keeps on recurring. But this is a number on the number line. So you can similarly, you can have many other irrational numbers. What are those? So this you have seen, I can have everything on root 2. Root 3, I can have root 4, I cannot have root 4 because root 4 is equal to plus minus 2, but we always consider 2. 2 is a positive side of 2. So 4 is not a irrational number, root 4, root of 4. But root of 5 is an irrational number. Root of 6 is an irrational number. Why? Because this would be root 2, root 3 into root 2. So this will be a irrational number. So if I can keep on writing, so if I keep on writing root 2, root 3, no root 4, but root 5, root 6, root 7, root 8, but not root 9, because root 9 is equal to 3, just like here. So root 9 is not irrational. And so you can have root 11, root 12, root 13. So you can go on except where they form perfect squares. Those you have to remove because they are not irrational. Other to this thing, you must have learned about pi. Many students say that they are very much confused about pi. It's not necessary. What is pi? It's very easy if you try to think about it. Okay, I will use this side. I remove this and I will talk about little bit about pi so that you are aware of it. How has pi come about? If you take a circle, okay, you have a circle. Okay, now what is the circumference of this circle? Circumference. You will say, I need diameter. Okay, let us say this is the diameter. The whole thing is your diameter. And radius is d by 2. Half of radius. So this would be d by 2. Okay, circumference 2 pi r, or that is equal to 2r. So or 2r is equal to d. So I can write down pi into d. Okay, now diameter is d. So if I take a ratio of circumference and diameter, what do I get? Circumference I will get pi d, and diameter I will get d. These two cancels and I will have pi. So there is nothing big thing about pi. So you can take make circles of various radius and you can find out this ratio and you will always come to pi. And this pi is a irrational number and this is 3.1416, something of this nature. Okay, and we approximate it sometimes by 22 by 7. This is an approximation. If you do not remember this, you can say, okay, this is 22 by 7. Okay, now these irrational numbers, if I take into consideration, so I will again go through it. I am repeating it after again and again, so that the whole concept gets into you. And here I will write it slowly and easily for you to understand. First, we started with natural number. And that we said n. Then we added 0, plus 0. I have done it before. I am doing it again so that you get that. This gives you whole number. So this whole thing plus negative numbers. Okay, let me erase this because I don't need this part anymore because I have already established the concept of pi. Okay, so you have that negative numbers. That whole thing will give you, so this is whole number is w, that will give you integers. Okay, so that you will denote as universally accepted as z, and we can do it again. So what is the big deal? Let me write it out, otherwise feel complicated. Okay. Okay? So this whole thing is integral. I have written integers. This is integers. Okay, this is Z. So integers plus fractions. Fractions means numbers within the space of two integers. Okay, so when I add these two, these becomes the whole thing. Whole thing becomes rational number. And when I add with these rational numbers, irrational number, that whole thing becomes real number. Okay, and this line, the number line, now takes into real number line. Is that okay? Now this is good enough, and you have been able to comprehend this one. So irrational number is also a part of your real number. And we must thank, okay, now I have said, so these very famous, because they are the first one to be investigated, pi and root 2. Then there is also a number called golden number. Golden number. And another number E. So these numbers are famous irrational numbers. I will not talk about, I'll talk about this one little bit later. I don't want to add too much so that to get you confused. They are not, this golden number and E are not in your syllabus. So I will not consider that now. But these two are, and this was the beginning. Why I am calling it beginning? Because once root 2 has been established, then say, oh, hey, why not others? What happens other? What happened to root 3? How do I get into root 3? The root 3 also was a very easy technique of doing it. For example, why I am again used to using that thing, so I am not using it. I should use it more, because then this thing will go away. How do you do this? Okay, you do this one. Again you take the number line, or now we are real number line, and you start taking 1 unit of the real number line. You make a perpendicular here, and also same amount. This and this is same. This is 1 unit, 1. This is also 1. So this gives you root 2. So this is root 2. Again what you do, you make a perpendicular here. On this hypotenuse, you make a perpendicular like this. And this is 90 degree. Okay? So you take again another 1 unit. You take another 1 unit. You take this one. So this is again another 1 unit. join these two. Okay, now if you take this right angle, what would be this one? This, let us call OAB. OA is equal to root 2. AB is equal to 1. Then what is OB? Then what is OB? OB square would be OA square plus AB square. That is, OA square is what? OA square is root 2 square. Root 2 square. AB square I have taken 1. So it's 1 square. So this is 2 plus 1. That is equal to 3. So OB is equal to root 3. So again you take this length, you take it here and you put it on your real number line. So this is a position here. For root 4, as I have said, that is not necessary. So you have got now root 2, there is also root 3. You don't need root 4, but you can go to root 5. How do you go to root 5? There is in the book, there is a number of ways it has been shown, but you can do it this way. Okay? To do, instead of going to that conversion way, why not take 2 units here? 1, 1 and 1. Here it is 1 unit and then here it is 1 unit. Draw a perpendicular here of 1 unit and then draw this line. Okay? So here you have got 2 units, 1 unit. So again do it, 1A, OB. So OA is equal to 2 units and AB is equal to 1 unit. Right? Okay. Do it the same way here. So I will erase and do it again so that it becomes doing it twice and you will be able to do it clearly. Okay, let me do it here. So here, so OB square is equal to OA square plus AB square. Okay, what is OA? 2 square. AB is equal to 1 square. That is equal to 4 plus 1. That is equal to 5. So OB is equal to root of 5. So take this thing here and draw it and bring it here. So you got the other point, which is root 5. I hope you have been able to understand and go through it very, very carefully. And I will again request you to like my channel and also subscribe on the channel. You like the video and you subscribe on the channel. And for the next part of this chapter 1, there will be another video and I think it will come within 1 or 2 days. Thank you and goodbye.